Our cosmic address is more impressive than we realize. When we think about our place in the universe, it's easy to feel small and insignificant. But in reality, we are part of something truly magnificent and grand. We live on planet Earth, a beautiful blue marble teeming with life floating in the vastness of space. Our planet is unique, with its diverse ecosystems and vibrant biosphere, orbiting a star we call the Sun, which provides the energy necessary for life to thrive. The Sun is just one of billions of stars in our galaxy, but it holds a special place in our hearts as the center of our solar system. But our neighborhood extends far beyond our solar system. The vast expanse of space is filled with countless stars, planets, and other celestial objects, each with its own story to tell. We are part of a vast, swirling city of stars known as the Milky Way galaxy. This galaxy is a massive collection of stars, gas, and dust, all bound together by gravity. Imagine a celestial disk, a cosmic pizza dough stretched across 100,000 light-years. This disk is home to billions of stars, each with its own unique characteristics and potential for hosting planets. That's the Milky Way, our home galaxy. It's a place of wonder and mystery, with many secrets still waiting to be discovered. Within this vast structure, billions of stars, including our Sun, orbit a central point. This central region is densely packed with stars and is thought to contain a supermassive black hole. From our vantage point on Earth, we can see the Milky Way as a band of light stretching across the night sky. This band is a beautiful reminder of our place in the galaxy. This band is actually the combined glow of countless stars, too faint to be seen individually with the naked eye. It's a stunning sight that has inspired awe and wonder for generations. For millennia, humans have gazed at this celestial river of light, weaving myths and legends around it. Ancient cultures saw it as a pathway to the heavens, a bridge between the earthly and the divine. Today, thanks to scientific advancements, we are beginning to unravel the secrets of our galactic home. With powerful telescopes and advanced technology, we are exploring the Milky Way in ways our ancestors could only dream of. Each discovery brings us closer to understanding the true nature of our cosmic abode. The Milky Way is a barred spiral galaxy. This means it has a central bar-shaped structure from which spiral arms extend outward, much like the pinwheel of a firework frozen in time. Our Sun resides in one of these arms, about 26,000 light-years from the galactic center. At the heart of the Milky Way, hidden from our view by clouds of gas and dust, lies a supermassive black hole, a gravitational monster known as Sagittarius A*. This black hole, with a mass millions of times greater than our Sun, exerts an immense gravitational pull, influencing the orbits of stars and gas in the galactic center. The Milky Way is a dynamic and evolving structure, its spiral arms constantly shifting and reforming as stars are born and die. Understanding the structure and evolution of our galaxy provides crucial insights into the processes that shape the universe as a whole. Stars, the building blocks of galaxies, are not eternal. They are born, live out their lives, and eventually die, sometimes in spectacular fashion. But what exactly happens during these stages of a star's life? Let's delve deeper into the fascinating journey of stars. The Milky Way is teeming with stellar nurseries, vast clouds of gas and dust where stars are born. These nurseries are the cradles of star formation, where the raw materials of the universe come together to create new stars. One such nursery is the Orion Nebula, a stellar maternity ward visible to the naked eye as a fuzzy patch in the constellation Orion. This nebula is a hotbed of star formation, with hundreds of young stars in various stages of development. Within these clouds, gravity pulls together clumps of gas and dust, causing them to collapse and heat up. As the material collapses, it forms a protostar, a young star still in the process of forming. The protostar continues to gather material from its surroundings, growing in mass and temperature. Eventually, the core of a collapsing cloud becomes so hot and dense that nuclear fusion ignites, marking the birth of a star. This process releases a tremendous amount of energy, causing the star to shine brightly. The newly formed star enters the main sequence phase, where it will spend the majority of its life. Stars come in a variety of sizes and colors, from small, cool red dwarfs to massive, hot blue giants. The size and color of a star are determined by its mass, with more massive stars burning hotter and brighter than their smaller counterparts. Our Sun falls somewhere in between, a yellow dwarf star. It has been shining for about 4.6 billion years, and is expected to continue for another 5 billion years. During this time, it will remain in the main sequence phase, steadily burning hydrogen into helium in its core. As stars age, they burn through their nuclear fuel, eventually exhausting their supply. When a star exhausts its hydrogen fuel, it leaves the main sequence phase and enters the red giant phase. During this phase, the star's outer layers expand and cool, while the core contracts and heats up. The fate of a star depends on its mass. Small stars like our Sun will gently puff off their outer layers, forming planetary nebulae. These beautiful glowing shells of gas are illuminated by the remaining core of the star, which becomes a white dwarf. White dwarfs are incredibly dense, with a mass similar to that of the Sun, but a volume comparable to that of Earth. They no longer undergo nuclear fusion and will gradually cool and fade over billions of years. Massive stars, on the other hand, end their lives in cataclysmic explosions called supernovae. These explosions are among the most energetic events in the universe, releasing more energy in a few seconds than the Sun will emit in its entire lifetime. The remnants of a supernova explosion can form either a neutron star or a black hole, depending on the mass of the original star. Neutron stars are incredibly dense, with a mass greater than that of the Sun, but a diameter of only about 20 kilometers. Black holes, on the other hand, are regions of space where gravity is so strong that not even light can escape. They are formed when the core of a massive star collapses under its own gravity. Supernovae play a crucial role in the universe by seeding the galaxy with heavy elements that will eventually become part of new stars and planets. These elements, such as carbon, oxygen, and iron, are essential for the formation of planets and life as we know it. Section 4. Searching for other Earths. In the vastness of the Milky Way with its billions of stars, it seems almost inconceivable that our planet is the only one harboring life. The sheer number of stars, each potentially hosting its own planetary system, opens up a universe of possibilities. Could there be other Earth-like planets out there teeming with life, or even civilizations far more advanced than our own? The search for exoplanets, planets orbiting other stars, has become one of the most exciting fields in astronomy. With each new discovery, we inch closer to answering the age-old question, are we alone in the universe? This quest has driven astronomers to develop innovative techniques and utilize some of the most advanced technology available. Astronomers have developed ingenious methods for detecting these distant worlds, even though we cannot see them directly. These methods often involve indirect observations, where the presence of a planet is inferred from its effects on its host star. This requires meticulous data analysis and a deep understanding of stellar behavior. One method involves looking for tiny wobbles in a star's motion caused by the gravitational pull of an orbiting planet. This technique, known as the radial velocity method, has been instrumental in discovering many exoplanets. The gravitational interaction between a star and its planet causes the star to move in a small orbit, creating a detectable wobble. Another method looks for slight dips in a star's brightness as a planet passes in front of it, blocking a fraction of its light. This is known as the transit method. When a planet transits or crosses in front of its star, it causes a temporary dimming of the star's light, which can be measured by sensitive instruments. These techniques have revealed thousands of exoplanets, many of them vastly different from anything found in our solar system. Some of these worlds are so exotic that they challenge our understanding of planetary formation and dynamics. From scorching hot Jupiters to icy super-Earths, the diversity of exoplanets is truly astounding. Some are gas giants orbiting closer to their stars than Mercury is to our Sun, experiencing extreme temperatures and intense radiation. These hot Jupiters have short orbital periods, sometimes just a few days, and their atmospheres are often bloated and turbulent due to the proximity to their stars. While others are rocky worlds located in the habitable zone, the region around a star where temperatures might allow for liquid water to exist on the surface. These planets, often referred to as Goldilocks planets, are of particular interest because liquid water is considered essential for life as we know it. The discovery of exoplanets, particularly those in the habitable zone, has fueled our imagination and intensified the search for life beyond Earth. Scientists are now focusing on characterizing these planets, studying their atmospheres, and looking for signs of habitability or even biosignatures, indicators of life. While we have yet to find definitive evidence of extraterrestrial life, the sheer diversity of worlds we have discovered suggests that we may not be alone in the universe. Each new exoplanet discovery brings us one step closer to understanding our place in the cosmos and the potential for life beyond our own planet. The search continues, driven by curiosity and the hope that one day we might find a world that mirrors our own. Section 5. The Enigmatic Galactic Halo. Surrounding the Milky Way's familiar disk of stars and gas is a vast spherical region called the Galactic Halo. This halo is home to globular clusters, ancient swarms of stars that orbit the galactic center like bees around a hive. But the halo also harbors a profound mystery, dark matter. This invisible substance, which does not interact with light, makes up the majority of the Milky Way's mass. We know dark matter exists because of its gravitational influence on visible matter, but its true nature remains one of the biggest unsolved mysteries in astrophysics. The galactic halo, with its globular clusters and enigmatic dark matter, serves as a reminder that much about our galaxy, and the universe as a whole, remains shrouded in mystery, waiting to be explored and understood.